Testing, 1, 2, 3. All right. Looks like the microphone is live. Looks like I'm live. That's good. All right, we're going to start in just a minute. People are hopefully able to connect. I know I'm connected, and we will begin momentarily. All right, I see people are appearing. That's good. Let me bring up a few things here. All right, we're going to start here in just a second. Just waiting for a few more people to arrive. All right, looks like we got critical mass. That's good. People have already started asking questions. That's good too. We'll cover the questions when we take the first break. Okay, so let's go ahead and get started. Welcome to the third live lecture for the POSA Communications MOOC. What we're going to do today is we're going to talk about the intent service, and I'm going to talk about how the intent service can be used to provide concurrent downloading or concurrent processing of intents, one intent at a time, running in a background thread. And then we'll also talk about the programming assignment that was released last Wednesday. And depending on how much time we have, we might also start talking about bound services. But we may wait and push that off until Wednesday, depending on how things look. Okay, so let's go ahead and bring up the slides, and I will do my best to remember to share the screen this time. Okay. So hopefully you can see the slides. Obviously, if you can't see the slides, please let me know. But hopefully you can see them. So let's see. I'm looking at my picture here, and I don't seem to see these things moving. So let me try again. I want to make sure this is working before I get much further along. All right, I think we're working. Okay, so what we're going to do today is we're going to talk about the Android IntentService. And we're going to talk about how it's a way of being able to program started services that concurrently process commands that are expressed as intents. And of course, you'll also see that this is a crucial thing to understand in order to do the first programming assignment. And you can find out more about the IntentService class, which is really a framework at this URL. Why do we have the intent service? Where did it come from in the first place? Well, it basically codifies a very common Android service concurrency idiom. And we talked about this idiom earlier when I talked about programming started services with intents and messengers. I showed you an example of how to program with that idiom. And basically, as we'll see, this involves a number of different components that are part of the intent service implementation, as well as leveraging stuff from the Hammer framework that we talked about before. And this is basically how things work. If you take a look at this idiom, the way it works is in the onCreate hook method for a service, a new handler thread is created and started, and then you get a thread-specific looper to the service handler, or rather, you get the thread-specific looper to the handler thread by calling thread.getLooper, which gives you the looper that's the thread-specific looper, and then you use this looper in order to create a service handler object, which has that looper as its looper. So that means that handler will run in the context of the handler thread. If you go back and watch the Hammer framework videos, you'll learn more about that. So that's how things get initialized. And then when somebody starts a service, when start service is called, that triggers the onStart command method to get called back. And what onStart command does is it goes ahead and it obtains a message, and it then stores some information into that message. It puts the start ID that was used to keep track of which particular intent or command was being passed in from start service, because every time you call start service, a different intent shows up, which is treated as a command from the point of view of the Android IntentService. And so the start ID, which is an integer, and it's incremented every time a new intent shows up by the framework, by the IntentService framework, that is then stored as the arg1 field of the message. And then the intent itself is stored as the object field of the message. And then that message is then sent to the service handler. And this, of course, is where it uses the Hammer framework. So the interesting part here is that the overall end-to-end abstraction is basically the command processor pattern. But then this portion right here inside of the implementation of the intents framework is effectively the active object pattern used to communicate from one thread to another by passing a message. And then the service handler's handle message method is going to get called back, of course, once the thread has a chance to run to take the message that was out of the queue that was put there by send message. And handle message will then turn around and process the message containing the intent. And what that does is it takes the message and calls download image and reply, and we'll talk about what that does later. And then it calls stop self. So that's kind of the canonical behavior of this idiom we were talking about before. And if you take a look at the Android source code, you'll see that this idiom appears in various packaged applications. So the alert service uses this, the SMS receiver service uses this, the MMS transaction service uses this idiom. It's a very common idiom that you see. And because this idiom was so common, the Android developers refactored it into a reusable framework. So whenever you find things that happen quite a lot, you find that the common way of handling this is to use a framework to embody the commonality and then reuse it in lots of different places. So we'll talk about how all the patterns get used here shortly. So let's talk about, now that we've talked about this idiom, let's go ahead and talk about the intent service and how it codifies the idiom. And this will also give us a chance to talk a bit more about the patterns. So the intent service codifies the idiom for concurrent processing of intents into this reusable framework, and it's very, very easy to use. It's sort of absurdly easy to use. All you simply do, so the intent service extends service, and it goes ahead and defines an abstract method called onHandleIntent. And onHandleIntent will be then available for extending by a subclass. So the subclass is simply override the onHandleIntent hook method to process an intent in a single background thread. Keep in mind, it only processes one intent concurrently at a time. That's very important to remember, because that's a limitation with the framework that is significant in terms of scalability. However, even though only one thing is taking place at a time, the processing occurs off the main thread of control, which means that if the service is running in the same address space as the activity that started it, if the intent service is running in the same application address space, the process address space as the application, the activity that started it, that will not cause problems with blocking the UI thread, because as you all remember, blocking the UI thread is a bad thing. So this allows this to take place off the UI thread. Now, there are other ways to do this, of course, and another way, which we'll actually talk about when I show you my solution to assignment number 1, is to use the Java executor framework to process intents concurrently in a pool of threads. That's not the behavior you get out of the box with IntentService. IntentService is not intended to be used with a pool of threads. If you want to use a pool of threads, then you have to write your own, thread pool service or something like that. And I'll show you how to do that later next week when we get done with assignment number 1. The client starts all this stuff. The client, which by the way is usually an activity, but it doesn't have to be, it's usually an activity. It sends intents via calls to start service. So what happens here is start service is called. Now, thinking about the command processor pattern, this is basically the invoker. So somebody's invoking this, and so that's basically where the command is being sent. So we're sending the command, which in this case is intent, by calling start service. And various types of data can be passed into a service by putting extras into the intent that's passed. Of course, you can pass multiple intents by calling start service multiple times, as we do with programming assignment number 1. And you can find out more about how to transfer data in intents by looking at this link. It's very simple. The intent service itself is launched on demand via the activator pattern. We've talked about the activator pattern several times. We'll talk about it again later in the course. And so this is basically the executor in the pattern. And so the executor then takes the command that comes in the command process pattern, then takes the command that comes in, and it goes ahead and runs it in the right context. And of course, that context is going to be a background thread of control. And the way that happens is that the subclass of IntentService implements the onHandleIntent hook method. And you can read here to find out more about how to do this. It's very, very, very simple, not too much to think about. The hook method processes the intent in a background handler thread. So under the hood, and we'll see the implementation here shortly, there's a handler thread that runs in the background, and it does all this stuff. And the hammer framework is used to send and receive the messages to the background thread. So that's kind of the active object. So the active object part is kind of localized inside the intent service. And then the command processor is really the overall abstraction where you're sending commands from a client activity, and those commands are then going to a different context, which happens to be a different thread, which might or might not run in a separate process. And then that thing goes ahead and runs concurrently. So it runs concurrently, but it's only one thing at a time that's running concurrently. But it is running concurrently with respect to the invoker. So it's a single-threaded concurrent solution as opposed to a multi-threaded concurrent solution. But it is concurrent with respect to the invokers. That's what it means to be running concurrently here. So there are definitely two things going on at the same time. The activity is running in one thread, and the intent service onHandleIntent method is running concurrently in another thread. But there's only one thing that's running concurrently in that thread at a time. Whatever the class is, I'm using download intent service here just to be concrete, but whatever the service is that implements this does several things. In our case, it downloads an image, and then it replies back to the download activity. And so that's basically what we're doing in this particular case. But obviously, you could do lots of other things. Okay, so that's kind of the high-level view of things. Let's now go ahead and talk about how the intent service works internally. So internally, and you can take a look at the source code here at this path name, which gets you the source code. I highly recommend, by the way, that you take a look at the source code because it really makes a difference in terms of understanding what's going on. So what it does internally is it basically follows that idiom that we talked about before that used to be hard-coded into Android. It creates a service handler, and starts a handler thread that runs in the background, and as messages come in, they're received, queued, and dequeued via the Hammer framework. And then once the single background thread pulls a message off the queue, it turns around and calls onHandleIntent on the subclass, and that then goes ahead and processes the intent in the background. And each time, whenever there's an intent that comes in, it's processed in the background thread. When that background thread is done, then it checks to see if there's any more work. Now, the key thing to remember here is that there's only one background thread, so only one intent at a time is processed, even though it's running concurrently. So again, it's kind of a weird distinction, but that's important to understand. The service is stopped when no more intents remain to process. So what this means is if a client is busily calling start service, and actually you can have multiple clients. If multiple clients are busy calling start service, passing intents into the intent service, then the service will not shut itself down. So as long as there's work to do, as long as things have shown up into the process, into the intent service where it's being processed, then we will keep going. Only when there's nothing else to do will the intent service go ahead and shut itself down. Conversely, if you did a started service, then you have to stop it manually by calling stop self. So you would have to manage the logic yourself with a normal started service, but the intent service handles that all for you. And the intent service is, again, very widely used. If you take a look at Android, you see it's used many places in Android's packaged applications. It's used in the calendar application. It's used in contacts, email, exchange, the music service, the phone service. There's all kinds of stuff that uses intent service. It's a really simple service to run if you just need to have something running in the background one at a time. And you can read more about the intent service here at this link. Okay, I'm going to take a few questions at this point, and then we'll talk about the implementation, how all this works. So the first question is, how is the command processor used? So I think I kind of went over that as I discussed the design, but basically, when the way the command pattern is used is that an activity or some other component, could be another service, calls start service. That's invoking the command. And the command object, of course, is the intent that's being passed in. And that intent is then sent over to the service using the activity manager service. And that intent is then delivered to the intent service. And the intent service then, under the hood, receives that via the onStart command method, which is just a good old service method. OnStart command, as we'll see in a moment, will go ahead and queue the intent along with the start ID in a freshly obtained message, and then it'll send that to the service handler, which is running in a background handler thread. And so at this point, we're still implementing the command processor pattern, but we're now using the active object pattern and the Hammer framework implementation of the active object pattern to pass the message containing the intent and the start ID from the main thread where onStart command is called to a background thread, to the background thread, which will then call handle message, and handle message will turn around and will call onHandleIntent, which is the callback hook method, and then that's basically where the call gets processed. So that's where the command processing takes place that's defined by the user. So it's kind of an interesting example of nested patterns. The overall abstraction is the command processor pattern, and then in the implementation of the intent service framework, they use the active object pattern, and of course they also use the thread-specific storage pattern in order to connect the service handler with the looper of the handler thread. So that's basically how the pattern is used. And we'll talk more about this later in the course, and I'll go into more detail. There's an observation. It's confusing to say concurrently one at a time. Well, but that's and the observation is because concurrently means happening simultaneously. Well, it may appear confusing, but that's exactly what's going on. So the processing that's taking place concurrently is running concurrently relative to the thread of control that invoked start service. But of course, there's only one intent at a time that's being processed concurrently. So it's not a pool of threads, or it's not a thread per request. It's one intent or one command at a time that's running in a background thread. So I know it sounds a little odd, but that's precisely what it's doing. And to not say that would be confusing. When will a started service have multiple clients? Well, anytime that you create a started service that runs as a process, a separate process, which of course is what we're doing in assignment 1, then you can have multiple clients that will go ahead and call to it. So there's really nothing to stop you from, or nothing to stop a person from creating a service that runs in a process, and then multiple clients can go ahead and bind, or not bind, they can go ahead and get intents that are explicit intents and then invoke start service. So that kind of thing is, we could do that easily. In fact, you could imagine our download image service as being something that could be used by many different applications. If we really put some time into doing it right, we could use the download image service by multiple applications. So there could be different clients that would be using it to download an image. And the other question was, how is the command processor and active object pattern glued together? So hopefully I've just explained that. And then one final question, they say the preferred way to communicate between an activity and intent service is to use the local broadcast manager and create a broadcast receiver object. So I think what is being said there, because obviously the activity is communicating to the intent service by calling start service. But certainly one way you can get the result sent back is to use a local broadcast manager, which is, I believe, intended to be local to a single address space. I could be wrong about that. And then you have a broadcast receiver that you can broadcast the intent back to when you're done. That's certainly one way to go. I actually find that to be more awkward for a variety of reasons, not the least of which is that over-reliance on broadcast receiver leads to all kinds of weird problems with Android with respect to security. So I try to de-emphasize the use of broadcast receivers whenever possible, because there are various ways to compromise them. Local broadcast managers alleviate some of those problems, but I happen to like the messenger approach. I think it's a lot cleaner in my mind, but it's certainly a way to go. You can certainly use the broadcast receiver. I think if you were also to look inside the implementation of Activity Manager service, you would see that the broadcast receiver implementation is rather complicated. And so that's another thing to keep in mind. I'm not sure what the relative pros and cons are from a performance point of view, but you can certainly take a look and consider doing that. I think I actually have some slides on that. Haven't really been covering them lately, but they are something that could be covered. Okay, looks like we have finished our round of questions. Let me go ahead and bring up the slides again, and we will reshare the screen. All right, go ahead and reshare this. So let's now talk about the intent service implementation. So the intent service, as you all know by now, handles async commands expressed as intents concurrently. There's a bunch of patterns it applies. This is actually sort of a recap of what we just talked about in the Q&A session. So the command processor pattern is used to provide the end-to-end abstraction here. So from client calling start service to on-handle intent being called back, that's essentially the command processor pattern. And you can read about the pattern here. We'll cover this pattern in a later section in a couple weeks. The active object pattern is used to communicate inside the intent service itself from one thread to another, and that's active object. And then we have the concurrent service stopping idiom, where, as we've seen before, the implementation of the intent service is going to call stop self, passing in the start ID. And if the start ID matches the most recent start ID, it shuts down the service. Otherwise, it does not shut the service down. And you can read more about that idiom here, where it explains kind of how it works very briefly. And I'll show you the code in a second. Here's what the intent service looks like internally. It extends service, and it defines a couple of useful fields. It has a service looper, which is a looper, and service handler, which is, those are used to hold values that'll be needed for the concurrent active object processing. They are defined as volatile to ensure the fields are properly visible to the background thread that runs. And when the intent service is first created, its onCreateHook method is called back just like any other service. That causes a new handler thread to be created. And you can see the implementation just basically says, hey, you've got to give it a name. So there's a name given to this thing. And the intent service doesn't know if it's running in a separate process or not. So it has to spawn a separate background thread. That is actually a bit overkill if it runs in a background process, but to make things easy to work with and transparent, they do it this way. The start method is then called to start the thread to run in the background. The looper is obtained from the handler thread, and that looper is then passed in to the service handler class, which we'll look at in a second. And then that's used to make sure that the service handler handle message method gets called back in the background thread. Okay. Now, so that's what happened when the service is started. So you can think of that as basically like a constructor. Here's the onStart command. This is called each time a started service is sent an intent via start service. And notice what gets passed in here is the start ID and the intent. And an internal helper method called onStart is invoked. And onStart goes ahead and gets a message from the service handler, and then it goes ahead and it sets the start ID and the intent to be fields in that message. And this is, of course, used as part of that concurrent stopping idiom that we're going to talk about in a minute. It then goes ahead and sends the message to the service handler to process things in the background thread, and we'll take up and see what happens next. Notice also that the intent, either the onStart command either returns start not sticky or start redeliver intent, depending on flags that you use, you can set when you create it. Internally, the Android Hammer framework is used to enqueue and process these messages in FIFO order using the active object pattern. Here's the service handler class. This is going to receive the messages passed to it from onStart command, or more specifically onStart, the helper method. It's going to use this thing in order to be able to receive messages. And the way it does that, of course, is by extending handler. And its constructor will stash away the looper, so it'll run in a separate background thread that the handler thread has created. And then when handle message gets called back, which is going to run in the context of the handler thread's looper, that calls onHandleIntent, passing in the message object. And of course, onHandleIntent has to be overridden by subclasses to do the work. And when onHandleIntent returns, then the implementation of the intent service calls stop self, passing in the start ID that was stashed away inside the message. So it's stopping the service using the start ID. So we don't have to stop the service in the middle of handling another job. And again, keep in mind the way this works is if onStart command has been called while this other processing is taking place, and there'll be a new start ID that was passed in. And so when we call stop self here, the start ID for this particular intent will not be the latest start ID if another intent has shown up concurrently in the meantime. So this again illustrates the concurrent processing that's taking place there. the thread that's doing the on-handle intent and the handle message call, that thread of control, is a different thread from the thread that's handling the on-start command. And so as a result, new intents can show up incrementing the start ID. They can be put into the queue in FIFO order. And so when stop self is called here, it will decide that it's not actually time to shut down, and it'll go ahead and let the next call back to handle message take place, which will handle the next intent. Now, this whole thing only works because there's only one thread running intents concurrently, one at a time. And the queuing is done in FIFO order. So a newer intent that has shown up will not be processed until the intent that's running concurrently in the background has finished. And there was an earlier discussion of this idiom outside of the context of intent service in the earlier presentation we did last time. But this is another example of where that idiom is used. And of course, it's baked into the framework to make it a lot cleaner. When everything is done, when stop self is called, that will trigger the onDestroy hook method to be invoked, which will then go ahead and shut down the looper, which will then cause the background thread to exit, and then the intent service object will go away. So it'll be destroyed until someone calls start service again with a new batch of intents to process. Okay, there's a number of usage considerations to think about for this. The approach here significantly simplifies the handling of asynchronous commands expressed as intents. That's sort of the purpose of this thing. All you have to do is override the on-handle intent method to process the intents concurrently. One of the really cool things about this is that this part of the code doesn't have to worry about runtime configuration changes. Unlike the discussions that we had in the previous class where we were doing things like running threads or running async tasks or using the Hammer framework or whatever, in the activity, we then had to worry about what happened when a rotation occurred, when a runtime configuration change occurred. That was a lot of complexity that we had to wrestle with there. And that's because we were doing the threading in the context of an activity that can come and go. When we use services, however, the service remains blissfully unaware that this is taking place. And so as a result, it's easier from the point of view of the concurrent processing that's running in a service because it's not affected when rotations occur. Now, the activity, of course, is still affected, and we still have to be able to handle that. But the concurrent processing portion is running in a background thread that is not affected by the rotation. So that simplifies the handling of runtime configuration changes. The limitation, of course, with intent service, as I've noted here a number of times, is its scalability is limited because there's only one intent at a time that's processed concurrently relative to the activity or component that called start service. So it's kind of like an HOV lane where you can't really pass anybody who's in front of you. You just are stored in FIFO order. You go one at a time. And of course, the way to get around this is to use some kind of thread pool, which is much more scalable, but it's also more complicated to stop correctly. So we will talk about how to stop thread pool services in a couple weeks, but it takes significantly more thought. And the idiom that's baked into Android's stop self method for a service doesn't work without some additional help when you start doing thread pools. And in fact, if you read the Android documentation, they basically say as much. They basically don't tell you how to do it, but they say it's harder, and it is harder, and we'll talk about how to do it later. Okay, so that's basically the end of the intent service slide. We have a question here. When I compare the download service we covered last week with the intent service, they look very similar. Only the intent service is taking away a lot of work for me. Is that true? Yes, that's exactly the point. And that's what I mentioned before about how intent service refactors a common idiom that appears in Android in multiple places so that you don't have to keep writing that code. Instead, you can let the intent service do it once and for all for you. And that is a very wonderful example of refactoring and how, as a good source code designer, you should take a look, find what is common, factor it out, make it a reusable framework or a reusable class, and then reapply it instead of having to rewrite that code over and over again every time. And so the intent service is a really good example of this refactoring process. Another question. So the looper handler is what happens under the hood with a subclass of intent service. All we need to do is override onStart command and onHandle intent. No, you're close, but you're not quite there. To use intent service, all you have to do, and please go back and watch the video if this is not clear. I probably said it about a dozen times in the video. All you need to do is override onHandle intent. That's the one and only thing you need to do, is to subclass intent service, override onHandle intent, and then of course you have to configure the service to run by putting it in a manifest file or whatnot. You have to do that too, but that's nothing out of the ordinary. Everything else is handled for you. On start command, on create, the way that things are stopped, handle message, send message, handle message, on start command, on create. All the things we just looked at under the discussion of intent service implementation are all the things that the intent service is doing for you under the hood. And the intent service is under the hood. It's using a couple of patterns. It's using the active object pattern and the thread specific storage pattern under the hood. And then it's providing as an abstraction to developers the command processor pattern. I highly, highly recommend that when I mention these patterns and you're not familiar with them, go and take a look at the links that describe them. And then that way you'll not only get a better understanding of what I'm talking about, but you'll also have a much better understanding of those design abstractions in general. So you'll not only know how the intent service works or whatever it is we're talking about works, you'll also have a better idea of how Android works. And more importantly, much, much more importantly than Android, you'll have a better idea of how people solve design problems in concurrent programs. And that's really the value of this material when all is said and done. I like Android. I like Java. Android is great. It'll probably be around for a while, but if we're being honest with ourselves, Android and even Java will not be the last abstractions for writing software that you'll ever run into in your life unless you quit writing programs tomorrow. So there'll always be other things that'll come along. You may need to move to different environments, different languages, different platforms, different middleware, different mobile devices, different cloud processing environments. All those things will come and go, but the patterns turn out to be very, very common. And so once you understand the patterns, it makes you able to either more readily understand how to use a set of existing APIs, or it also makes it easier to develop stuff if you're on a platform that doesn't provide those abstractions out of the box. Now, the good news is more and more platforms provide those abstractions out of the box, but not everybody has the luxury of working on the latest and greatest stuff. So knowing the patterns can help you in all kinds of interesting ways. Okay, let's see. It looks like we've kind of run out of questions for the time being. If there's more questions, please go ahead and ask them. But what I'm going to do is the following at this point. So I had originally thought about maybe starting the bound service discussions today, but I think I'm going to wait and cover bound services on Wednesday, and that'll coincide with the releasing of the next programming assignment. So the next programming assignment will go out on Wednesday, and the next program assignment is a variant of the one that we're doing here for programming assignment number 1. The main difference is that you'll be using a bound service instead of the intent service, so that'll change a few things. And then we're also going to be using a thread pool as opposed to using the intent service with only one thread at a time that's running. So I'm not going to cover the bound service stuff today because I want to have that coincide with releasing the next assignment. So what I'm going to do instead is I'm going to go back and we will cover the newest and greatest implementation of the skeletons for programming assignment number 1. And I've made a bunch of changes based on feedback and bug fixes and just thinking things through, which doesn't actually change any of the code that you have to write, but it does change the way the shells, the skeletons look. And so I want to have a new video that explains all this stuff. So if people are trying to understand how the skeletons work, they can see the latest and greatest implementation. So if we go up here, here is the skeleton manifest file for assignment number 1. You can see it uses SDK version 19 or 22. I've been using version 22. It works fine. You can also use version 19. Some versions of Android 20 don't work properly for a variety of reasons, which is why I was encouraging people to use version 22. But you can also use version 19. It won't be the end of the world if you do that. We have to ask for certain permissions in order to be able to get access to the internet and read and write the data. We have a main activity, which is kind of the master of ceremonies. It kicks everything off. We have a display images activity that's used to display the images that are passed over and stored in a directory. And then we have a download image service, which is going to run as a remote process. We don't have to run this as a remote process, by the way. I just did that just to illustrate that you could do it. If you didn't want to run this as a remote process, you could always remove this and it would work just fine. Okay, so, oops, they resized this thing so it's a little bit easier to see. There we go. All right. So other stuff, just to point out, there's a layouts directory, which has the layout for the main activity, which if you look at the program, people have been posting videos that show how it works. It has a bunch of buttons that prompt you for various things and some other stuff. And then the source code all lives down here. We have 4 directories. We have activities, operations, services, and utils. Let's take a look at activities. We'll start with lifecycle logging activity. You should all know this by now. It's just the activity that's used to print out and log when things are happening. Here's main activity. This is a lifecycle logging activity, and it's also a service result. Take a look at that later. That allows a hook method to be called back. This method here called onServiceResult, which is used to pass back the results after we've downloaded an image. We'll come back and look at that in a second. Tag, actually we don't need this tag. Let me get rid of that because it inherits it from lifecycle logging activity. We have a retain fragment manager, which is used to handle rotations. We have an image ops, which is really where all the behavior and state reside. The onCreate method sets the layout and then handles any configuration changes that may have occurred. Handle configuration changes, basically check to see if this is the first time in or not. If it's the first time in, it uses the retain fragment manager to check for the first time in. And if it is the first time in, it makes a new image ops, which is, as we'll see, where all the real heavy lifting gets done, and it stores that into the retain fragment manager. If it's the second or subsequent times in, we go ahead and look up the image ops state, and we get that, and then we go ahead and tell it a configuration change occurred, and that re-updates some internal fields that it needs to have reactivated and reinitialized when configuration changes occur. And then we've got a bunch of methods that are connected to the buttons that you can click, like download images, add URL, and delete downloaded images, all of which is forward to the image ops object. And then we have onServiceResult, which is used to handle the callbacks. So that's basically what main activity looks like. Display activity is basically just an activity that also extends lifecycle logging activity. And its whole purpose in life is effectively to take the string that's passed in, which is a string to the directory path. It's the directory path containing downloaded images. So it goes ahead and it takes that string and it's going to use that as the place where the images will be displayed. And it's also got a factory method that makes an intent that can be used to start this activity. So you can imagine reusing this for all kinds of things. Maybe one of these days we'll come up with an even cooler way to do this that allows us to be able to scroll through the images, etc. But for right now, it just displays them. And I'm absolutely guarantee you this could be improved. In fact, we improved it a bit to make it more robust to various kinds of error checking and so on. If people have further improvements they'd like to add, let me know. Feel free to send them. We'll be happy to add them. Here is operations. This is really the workhorse of the whole thing. It's got a lot of methods in it. It keeps track of the operations. It knows how to do. I'm building for the future because at some point I'm going to add more stuff here to do image filtering and so on. We're just downloading right now, but right now we do download image is the only type. We have a weak reference to enable garbage collection, a bunch of fields that handle the edit text, linear layout, progress bar. These are sort of the views that we're going to use. We have a thing called a service result handler. We also keep track of the number of images to handle, which is the number that are going to be downloaded, and then the number that have been handled, so we can figure out when to go ahead and display the results. Keep track of the string that's used for the directory to store all the downloaded images. We keep track of all the images that have URLs that have been entered. The constructor for this thing goes ahead and initializes the fields. We initialize weak reference. We create the service result handler. We'll look at that in a second. We create a unique timestamp so we can have the images stored in a unique directory. That's something that could be changed. There are obviously other ways to do that. We make a list of the URLs that will be stored initially empty. Then we initialize the view fields and we reset the non-view fields. You'll see how those things get used in a minute. Initialize view fields just basically initialize all the fields that are views by using find view by ID. And reset non-view fields just kind of sets everything back to a default state, which occurs under a couple of circumstances. Here's start downloads. This goes ahead and hides the keyboard, checks to see if any images were provided, and prints an error if they weren't, or prints a toast if they weren't. If there were images, we start the download progress bar, which also could be improved to show % downloaded, but I just used an indeterminate progress bar to make things simple. Here was a little change that I just added recently. We keep track of the number of images to handle based on the size of the URL list. And then we go ahead and start downloading all of those images. And we have to do this up here to avoid race conditions. So now we know how many are going to be downloaded. We go ahead and start downloading them. Start download, as you can see, makes an intent, and it passes in the activity as the context, the request code, which is download image, as a number, the URL where to get the image, the directory path name to store the result, and the service result handler, which is used by the service to pass the result back. And that comes back through on service result to the main activity, as we saw earlier. Then go ahead and start the service, passing the intent in. So that's how things get started. And then as they complete, as you saw before, the on service result hook method gets called back on the main activity, which causes do result to get called back, which increments that we now have one more image that has been handled. And we check to see whether things succeeded or failed. If the request result code was result canceled, then we go ahead and handle download failure. You can see I'm kind of being a little lazy and just reusing the activity result okay and result canceled. I could also change that to service result canceled and service result okay. That's probably a little cleaner, although there are no such things in Android, so I just reused activity because it worked. We then go ahead and if it fails, we print out a log message, and then we go ahead and we try to display the images that have been received successfully. So that comes next. If all the downloads have completed, if we've downloaded all the images that we were expecting to download, we then turn off the progress bar, reset the non-view fields for the next run, And then we go ahead and check to see whether or not anything has been downloaded successfully. And if there has been anything downloaded successfully, we go ahead and call display images activity, which will start a new activity that will display all the images in that directory. And then we go ahead, we make the intent to do that, and then we go ahead and start that activity. Otherwise, all the images have not finished downloading, so we just bail out, and we expect this will get handled next time the try to display images method is called, or some subsequent time when they're all downloaded. On failure, we go ahead and figure out what the original URL was we were trying to download, and we remove that from the user interface because it was not a valid URL or didn't correspond to an existing URL that could be downloaded. And if all the downloads have completed, we then go ahead and dismiss the progress bar. We have a couple of helper methods to check to see if the downloads are complete or not. All downloads complete checks to see if the number handled equals a number to handle, and there was more than one to handle. And then we also have a method that checks if downloads are currently in progress. So if the number of images to handle is greater than 0, then there are downloads in progress. Here's add URL. Add URL goes ahead and is called back when a user wants to add the URL. It grabs the string, checks to see if it's syntactically valid. It doesn't check to see if it's there or not, just checks to see if it's syntactically valid. And if so, it adds it to the list and it displays that list. Otherwise, it pops up a toast saying something was wrong. Here is remove URL, which goes ahead and checks to see if the URL is in the list, and if so, it takes it out. And if all the downloads are complete, if we remove the last one, for example, we make the visibility of the progress bar disappear and display the GUI again. Here's what display URLs does. It removes all the views, and then it goes through and basically updates views to the linear layout and then displays them. Here's how we delete all the images. This is another button click that you can do where you click delete downloaded images. That goes ahead and deletes the files recursively and then prints the results and resets the fields for the next run. Delete files is a recursive method, which basically goes ahead and takes the path name that were passed in, finds the list of files there. If there are no files, it returns what it was passed in as the file count. Otherwise, it goes ahead and recursively deletes all the various sub files that are there. So everything's cleaned up. And here's the final method in ImageOps. This is called onConfigurationChange. This is what's called back after a reconfiguration occurs by the main activity. And it goes ahead and updates the service result handler, telling it to update itself because the activity has changed. It initializes the view fields. If all the downloads have completed, then we're done, and it hides the visibility bar, progress bar. If they're downloads in progress, it resets the progress bar and redisplays the URLs. So this is basically what ImageOps does. As you can see, this is by far the most complicated method in the class, or in the complicated class in the solution. Here is service. This is, of course, is what you have to implement. So download service is an intent service. That means, of course, that you'll have an on-handle intent method. That's the main thing that you need to fill in. That's the one that actually does the heavy lifting. All the other methods here are just helper methods to help this work properly. We've got various things, various strings like messenger, image path, request code, image URL, directory path name. These are all basically keys that are used to store extras into the intent. Here's the make intent method that you have to write. Basically, you have to take all the things that are passed as parameters, and you have to go ahead and make an intent, and you have to store those things as either the data or as extras. Note, by the way, that make intent is called directly by the activity, or it's called in the context of the activity by the ImageOps object, and it doesn't actually go to the process that's handling the intent. It's running in the same process as the caller. Only the stuff that's going through the on-handle intent mechanism, the stuff that corresponds to start service, actually will run in a background process. These are a bunch of helper methods: get image path, get result code, get request data, get image URL, et cetera, et cetera. These are just there to make it easier to write code that doesn't expose the details of setting and getting fields from intents or bundles or messages and so on, kind of shielding that and hiding that from the actual application logic so it's cleaner. There are different ways to do this. This is just the way I did it. There's the hook method, where you basically have to use all these methods we just talked about to extract things out. Send path is a method that's used to create a reply message and then send the message back to the main activity. And of course, you'll be using the make reply message factory method, which is defined down here, and you'll be using the messenger that was passed over as part of the original intent. You'll be using that in order to be able to send the result back, and make sure that you properly check for exception handling. It won't let you compile the code unless you handle the exception that can occur here when you call send on a messenger. And make reply message is just a factor method. You go ahead and do the things that are described here, and pay careful attention to how you do this. A lot of people are having subtle bugs in their code, and it's because they're not doing the right things here. There's basically a protocol that's being set up to determine the data formats, the data model of what goes back and forth, and these factory methods are what do that. So that's download image service. And then the final things we have here are some of the utils. We have retain fragment manager, which we've talked about several times before, and basically it uses Android's fragment manager to keep track of whether something's the first time in or not. And if it's the first time in, it creates something called retained fragment and stores it in the fragment manager, as we see here. If it's not the first time in, it just says, hey, this is a subsequent time in. I've already been initialized. And then it's got a bunch of helper methods that put and get the keys to strings that are corresponding to objects. You could also get the activity that's associated with the retained fragment. Retained fragment is a fragment. It has a hash map that's used to store the keys and the objects corresponding to the keys. Its onCreate method basically retains the data, so it'll survive runtime configuration changes. And then it's got put and get methods that forward to the corresponding methods in the hash map to store this information. Service result is just a clever little interface that's used to allow an activity to have a way to get service results back to it, much the same way that an activity has a way to get activity results back if you start an activity for result. Same kind of thing works here. The service result handler is a handler, and what it basically does is it stashes away a weak reference to the service result, which in this case would be the activity, the main activity. It has a method to refresh the result when a configuration change occurs, and it's got a handle message method that takes the message that's passed to it, which is of course going to be coming back from a service, from the download image service. When you call send on a messenger, that ends up calling this handle message method, and that will go ahead and crack open the message, get the request code, we'll get the result code, and we'll get the data. And then, assuming that the result handler hasn't disappeared, we will go ahead and call the on-service result method on the result handler, passing in the information, the request code, the result code, and the data. Again, there are other ways to do this. This is not the only way to do it. It's not even necessarily the best way to do it. It's just a clean way to get results back. And I find it useful for thinking about things like that. And then the last method, the last class, is just a utility class that stores the code for downloading an image. And it's got a few other things that we don't really use a whole lot here. We can set toast, we can set activity result. We don't use that in this case. We can hide the keyboard and so on. This is just my place for putting stuff that I need to for the programs to make them easier to work with. Okay. So that's basically another walkthrough of the skeleton code for the assignment. I see a lot of people seem to have it working I appreciate everybody's feedback on improving the skeletons. I think it's more robust now. So if you're having problems, make sure you pull the latest and greatest version that's in the repo. Any changes that you pull over should not affect your implementation code. You're just implementing that one file, the download image service. And so, as long as you have the latest version by the time peer evaluation starts, we should be in good shape. Okay, let's take some questions. The first is actually an observation, not a question. It says, one way to keep your job is to master patterns. That is absolutely correct. I have, if you go back and watch the POSA 13 MOOC that I did 2 years ago, you will see in section 2, there's a whole discussion about design patterns. And I have a little case study of how design patterns have more than once helped me keep my job when I moved, when the company I was working with moved between different implementations, different platforms, Solaris to Windows NT was one example, between different frameworks and so on. And knowledge of the patterns has been invaluable to still being relevant, even though some of the technology changes out from underneath you. If all you know is a specific technology like Visual Basic or C++ or Java, and you don't understand the patterns, then when the technology base changes, you will find yourself with a lot of scrambling to do to learn a bunch of new stuff. In contrast, once you understand the patterns, when you move to a new technology base, it's often largely a matter of readjusting the way you expressed your patterns in one language or one platform to the way in which a new platform or a new language expresses those patterns. Now, of course, there are often new patterns to learn, but you're much, much better off having an understanding of the patterns because it'll save you from being irrelevant or obsolete. The next lecture will be on Wednesday this week. We'll do it on Wednesday, the 13th, 2 days from now. Oh, here's a good point. Monty has a great point, or great question. So is there a way to set breakpoints and step through code in a separate process? So I know in Eclipse, for sure, there are ways of setting breakpoints in background processes. I don't know the trick for doing it in Android Studio, but there must be a trick for doing it. So I just don't know the trick for it. The context for downloading will be the intent services context. Yes, that seems to work just fine. Can you please highlight your thought process on identifying patterns to identify and apply when I solve a problem? Well, as you've no doubt noticed, if you go back and follow the discussions of these things week by week, especially if you go back and watch the videos from the first MOOC and see how things have evolved, it's actually a really good microcosm of the process I typically go through. So I start out by, taking a look at the problem at hand, like downloading and filtering images. And I want, of course, that since this is an Android course, I want to showcase Android components as much as possible and features. So we're going to use activities and services and fragments and those kinds of things. And then I start, kind of writing up my solution. And inevitably, there's some patterns I know about already, and I use them just because I always use them. So you no doubt noticed that I always like to use factory methods to make intents because I like the way it shields the implementation from the use. So there's always a make intent defined on a service or something else. So that's a factory method pattern. I apply that one all the time. There are also, of course, a bunch of patterns that are already implemented in Android, and I'm simply a consumer of those patterns. So the Android Hammer framework uses the active object pattern. The Android async task framework uses the half sync, half async pattern. The Android IntentService uses the command processor pattern, and there's also the command processor pattern is also used for one of the variants of the Hammer framework, and so on and so forth. So, the minute you start programming with Android, you're already using a bunch of patterns. But then I also start looking for other patterns. I start looking at my code. First, I try to get it to kind of work, and then I want to go back and I want to refine it. I want to find a way to take things that are non-cohesive and non-uniform and make them uniform. And then I start applying more gang of four patterns or more POSA patterns. So you'll see I tend to use strategy. I like to use state. I like to use other gang of four patterns a lot. Strategy is probably strategy and state seem to be very common ones these days. Sometimes template method turns out to be a useful pattern. And so the code gets refactored, and I refactor it over and over and over again until I reach a point where I'm satisfied that I can't think of anything else cool to do with it at the moment. And then I'll typically, put that out. People will give me comments. I'll look back over it as comments come in. That'll often trigger, hey, there's a better way to refactor this code. Go back and redesign it, rewrite it, refactor it. And then as I'm working on new assignments based on the older stuff that we've done, I'm trying to find ways to reuse a lot of what we already did for the later assignments, because I want to show the continuity of the solutions. And I keep trying to find best practices and best techniques for using Android properly. And so what happens there is that as I come up with new requirements, let's say I want to add support for bound services instead of started services or intent services, I'll take the existing solution, I'll refactor it to work with bound services, and that may trigger reconfiguring and refactoring the older code as well to be more generalizable, to work for something new. So the bottom line is it's a never-ending process of commonality and variability analysis repeated endlessly as I come across new requirements, new features, new things I learn about Android, run across glitches in my understanding, keep trying to find ways to improve. So that's basically what's happening there. And the only way to get to that point is to do it over and over again. And sometimes you'll find out that you do it wrong a lot, and that's actually very valuable. Doing it wrong can often give you a lot of great insights. If there are improvements or bug fixes, how do you submit them? You can certainly send pull requests via GitHub. The other thing to do is just post them to the message group. Various people have been doing that. That seems to work pretty well. If I don't respond right away, send me an email. That's fine. But if you take a look, various folks, AJ and Monty and so on, have been posting bug fixes, and I've been integrating them as quickly as I can and pushing out new releases. So the new skeletons are way more robust than the ones were initially, and that's partly because I was rushing to get the thing done so I could release it as an assignment and didn't have a chance to work through all the corner cases. Are there specific graphical representations of several patterns for architectural sketching? If so, where could you find them? So that's a good question. I'm sure that if you were to get some of the more advanced drawing tools like Rational Rose or whatever they're calling it these days, Rational Architect or whatever, those probably come pre-baked with a bunch of existing patterns. That would not surprise me in the least. I just redraw them. Actually, a lot of what I do these days, honestly, I have patterns from the books I've written that I reuse those diagrams or slight variants of them. And then I also use the Object Aid plugin to Eclipse to be able to reverse engineer the code, reverse engineer the UML diagrams from the code. And then once I have those, then what I'll simply do is just go into PowerPoint, cut and paste the PNG files of the images, and then I'll overlay the roles of the patterns over top of the classes themselves, using the UML notation for pattern role, which is basically looks kind of like a lasso, a dashed oval with the role that the class plays in a particular pattern. And if you take a look at some of the presentations I've done, if you go back and watch, for example, one of the presentations on my solution to assignment number 3 for the first POSA concurrency MOOC we did a couple weeks ago, you'll see an example of how all that works, where I was able to add those pattern roles to the diagram. So that way you can kind of see at a glance, oh, this is playing the role of the concrete strategy in the strategy pattern. Oh, this is playing the role of the template method in the template method pattern, or the abstract class, or whatnot. So those are good ways to kind of learn about that. Okay, so that's basically. Oh, someone wants to know what was the name of the plugin I mentioned. It's called Object Aid. Let me see if I can start up Eclipse, and I'll show you how it works. That might be a useful thing to do if this doesn't take too long. I'll show you how to use it. It's really a very helpful feature. my Eclipse implementation is taking a little bit of time to start, but it should be up here in a second. There we go. All right, so let's go and see if we can share my Eclipse. There it is. So let's go ahead and find something here. Let's go look at, oh, I don't know, how about this? So we go ahead and say new, other, object aid UML diagram, class diagram, and we'll put it here. And we'll call it something really novel like foo. All right, so now we have something called foo, which is a view, as you can see in Eclipse. Enlarge it a little bit. And then we can go over here, we can just start dragging in the class. So here is main activity. And we'll just stick with this one for now. I'll make it bigger. So you can see that, let's see. Main activity is a lifecycle logging activity, and here are the methods it defines. Display images activity is also a lifecycle logging activity, and here are the methods that it defines. This also defines a nested class called image adapter, which is nested inside of display images activity. That's what that little cross symbol means. And I can also come along here if I want to, depending on what I want to show, and I can say, please get rid of the stereotype. I don't want to have a stereotype. I don't really care about that. Please get rid of the package name. Just want to show the class. I can come along and say, please get rid of all the attributes. I don't want to show any of the attributes. I could say, please get rid of private methods, or maybe I could even say, let's get rid of protected methods. Now a lot of things go to nothing. And I can auto lay out the diagram so it'll look a little cleaner and stuff like that. So you can basically do that kind of stuff with the tool, and that's what you get with the freely available tool. There's also a version that costs something, and I believe if you pay for it, you get the ability to do sequence diagrams, which are also very cool. But that's basically what I have for this. Let's see if I can come along here. Let's bring in service result. So you can see main activity implements service result, and service result handler kind of sits out here by himself. Retain fragment manager. Oh, that's an interesting one. Let's see if we can clean that up a little bit. So, I'm just playing around with this. You can get more or less detail depending on what you want to show, and you can also move things around to rearrange stuff so it's easier to view and so on and so forth. So that's basically how it works. It's pretty cool. I've used it a lot for the presentations and articles and things that I write. Someone asked, is there a similar tool for Android Studio? I don't know. Maybe there is. If somebody knows about that, let me know. Yet another reason why I use Eclipse, because that works nicely out of the box. I also write a lot of code in Java 8 these days, and Android Studio, as far as I can tell, doesn't really support Java 8, although IntelliJ does, but not Android Studio, which seems kind of strange. Okay, well, it looks like we've gone through the bulk of the stuff. If there are any more questions, I'm happy to take them. Otherwise, I will send out the announcement for the next class we're going to do, and we will plan on getting together soon. And we will talk about bound services next time, and I will go over the next programming assignment. Talk to you later. Bye-bye.